Pre-AP, Pre-Calculus, Notes 8.2, Properties of Logarithms. These properties, boy, you need to know these properties well. First property is called the product property. If you are adding two logarithms and they have the same base, you can rewrite this as one logarithm with that same base and multiply the arguments. You have a new argument, which is the product of the original two arguments. Now this happens whether your base is explicitly said or if it's implicitly in E, like these ones. This is going to be the same as natural log of AB. That is equivalent to natural log of A plus natural log of B. Now, the reason this should make sense, remember our logarithm is an exponent. If you're multiplying two bases, you add the exponents. So for multiplying, add the exponents. Quotient property of logarithms. If you have a logarithm and you're subtracting a logarithm with the same base, you can write this as one logarithm with the same base that you originally had, and you take the positive terms argument and divide it by the negative terms argument. Same can be true for common log or natural log. Natural log of A minus natural log of B is the same thing as natural log of A divided by B. When you're subtracting with the same base, you can divide the arguments. That's the bottom line. Property of equality for logarithms. If log base b of m is equal to log base b of n, now once again they have the same basis. So we have one expression equal to another expression. They're both logs with the same base. You can simply set the arguments equal to each other. Power property for logarithms. If you have an argument that has an exponent, you can take that exponent and you can write it as a coefficient in front of the logarithm. So log base b of a to the n, we could write as n times log base b of a. Same is true here for natural log or for common log. Natural log of a to the n, we could write as n times natural log of a. And we got two log identities. Log identity 1, log base b, and your argument is b to the n. This is equivalent to n. Let me explain why that's the case. I'm going to color code these b's differently. Remember what this question is asking here. It's saying b, that's the orange b, to what exponent is equivalent to b to the n. And that second b there is the red one. Now it should be obvious. B to an exponent should be equal to b to the same exponent. So these exponents have to be the same. So that's why this identity should make sense, hopefully. This one here, natural log. Now you might be asking yourself, well, do these have the same base? Well, they do, because if you have a natural log, it's implied that the base here is e. So once again, the bases are the same. So this is equivalent to just the exponent. That's log identity number 1. You don't have to remember if it's 1 or 2, but you have to know the identity. Log identity number 2, very similar to log identity 1. If you have a base raised to an exponent, and that exponent is a logarithm that has the same base as the big base, this all is equivalent to the argument. E to the natural log of a, well, e has a base of e, and natural log has a base of e, so this is also equivalent to the argument. If you think about this as b to the natural log of b to the a, let's say equal to some variable, this is currently in exponential form. If you write it in log form, so if I add a log to this, and I take the original base, and I have the argument as x, this should be equal to the original exponent, which is log base b of a. So this goes back to the property of equality right here. If you have two logarithms equal to each other and they have the same base, you can set the arguments equal to each other. So we're saying here that x would have to be a. That's why these we're saying are a. So let's quickly just look at some of these in action, specifically the product property and the quotient property. It says using only your calculator when needed, find the value of each of the following expressions. So we're suggesting that this expression and this one are the same, because the product property says if you're adding two logs with the same base, you can multiply the arguments. 9 times 3 is 27. Let's see if this actually works. So what is this first logarithm saying? It's saying 3 to what exponent is 9? Well, that would be 3 to the second. So this is equivalent to 2. Plus the second one, 3 to what exponent is 3? That would be 3 to the first. 2 plus 1 is 3. Well, let's look at this, which we're suggesting is an equivalent expression. 3 to what exponent is 27? Well, that's 3. 3 times 3 is 9, times 3 more is 27. Check out this next one. If we are subtracting two logarithms with the same base, you can divide the arguments. 32 divided by 4 is 8. So we think these should be the same. 2 to what exponent is 32? That's what this is asking. That would be 2 to the 6th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is, wait a minute, that would be to the 5th. Make sure I did that right. 4 and 4. 4 times 4 is 16, times 2 more is 32. So that would be to the 5th. And then log base 2 of 4 is 2 to what exponent is 4? That would be to the second. 5 minus 2 is 3. Over here on the right, 2 to what exponent is 8? Well, that's 3. 2 times 2 is 4, times 2 again is 3. Looking at number 3, 2 to what exponent is 8? Well, that's 3. 2 to what exponent is 4? That's 2. 3 plus 2 is 5. Over here on the right, these are equivalent. Let me emphasize these are equivalent. 2 to the 5th is 32. Last one, 4, and once again, we're just looking at the product and quotient properties in these. 3 to what exponent is 81? Well, that would be 4. Minus 3 to what exponent is 9? That's 2. 4 minus 2 is 2. And then if you take the quotient property, we're subtracting two logs with the same base, divide the arguments. 81 divided by 9 is 9. That's how this is equivalent. 3 to what exponent is 9? It's 2. So this illustrates, at least in the examples that we've shown, the product and quotient properties work. So a couple more and we'll stop this video. Using your calculator, find the values of each of the following expressions. These are just emphasizing the power property. Log base 2 of 5 to the second is 4.644. If we take this 2 and put it in front, it should be the same. If you put this in your calculator, you will find this is also 4.644, which illustrates that it is the same. Natural log of 5 to the second is 3.219. Power property says we can take the exponent of the argument and write it as a coefficient, which is what this is showing. This is also 3.219. We're going to stop this first video, and then we'll look at lots more examples that we can hopefully learn from.